we would like to continue with the last talk before the break, which is about the Android debug bridge from Gabriel Cirlig. Gabriel is a software developer and a so-called bot hunter at White Ops, located in London, UK. In the past, he worked on threat intelligence, and he obviously loves to dismantle, break, and fix all kinds of hardware he can get his hands on. Today is going to talk about the Android debug bridge and how his self-made honeypots discovered worms abusing this networked debug interface. So please welcome with me, Gabriel.
Hello, fellow humans, and thank you, Eric, for the introduction. Let me just share my screen. Is it all good?
Yes, we can hear you and we can see your screen. All perfect.
Awesome. So first thing first, thank you for having me here. I'm gonna show you today some neat tricks that are not being understood well by the hardware development community. But first thing first, I want to know you a bit better. Hang on a second. I need to find a way to see the window, the participant window. So raise your hand, whoever is an Android developer. Could you please just raise your hand? All right, we've got 2 people. 3, okay, 4. So we've got a nice audience. For those who don't know what ADB is, it's basically Android Debug Bridge. It's a developer's way of communicating with the device and building a debugging bridge, hence the name, between the app that's being debugged and the developer's computer. And today we're gonna look into ways that this is being abused by the bad guys. At least a vendor's generosity into allowing easy debugging of their device is being actively exploited by the bad guys. And now a bit more about me. So I haven't started my security research career for long. I pulled the stunt a few years ago. People nicknamed me the public transportation hacker after I did a simple MiFare hack with the public transit system in Romania. And after that, I discovered that I couldn't hack my way through the town anymore. So I started hacking my car. I found out that it knew quite a lot, definitely a lot more than I knew about myself and about the people that were roaming around that car, but that's a story for a different time. And recently I started hunting bots at White Ops. Hopefully we're gonna prevent the next robot insurrection, but right now we're just preventing them from doing ad fraud. And this little tiny bit of research kinda started from the fact that we have smart TVs, smart fridges, smart toasters, smart cars, and even smarter toasters. So what we can do if we want to stay safe is sprinkle our little honeypots in between all of those smart devices and the IoT, where S stands for security, as we all know. And looking at all of this landscape, something caught my eye. It looks like among this rubble of smart devices, some of them were being noticed by the bad guys. And it was mainly Android devices who had ADB on. This was being spotted by Kevin Beaumont at around 2 years ago, I think. I can't recall exactly. I still remember that it was summer, so it might be 2 years ago, which kind of prompted me into trying to figure out what are they sending to those devices. Is it, what are they exploiting? How are they exploiting it? Can I exploit it as well? So a lot of questions going around in my head, basically being a protocol that you can use to connect to, you can push binaries to it, and you can also send shell commands through ADB to that phone. Because guess what? At some point in history, ADB got externalized over TCP/IP. So even though initially the protocol was designed for USB only, at some point, the powers that be decided to put it up on the internet, and anybody can just type ADB TCP/IP and the port, and bam, then ADB is exposed on all of the interfaces that your phone has, or TV, or DVR, or whatever, on the internet. And that's when you're owned. So I started working. I started tinkering and hammering away, trying to just find a way to do it, just put in the hard work and read RFCs, RTFM, and you should be able to do it. And I did read the manual, the one that we have from Google. All of there is documentation for everything that's going on, but it's very outdated. That stuff was written once when the protocol was made. They even described the flow through ASCII art, but fortunately the community came to the rescue and they decided to compile and add more resources on top of that. But it was still not enough. So I had to dig a bit more. Fortunately, I found some people who reverse engineered most of the headers and the message body. And initially, at least according to the RFCs, on an ADB packet that's being sent over TCP/IP, you have the command, you have the two arguments, only two. The length of the data being transmitted, the CRC, and some magic. Simple enough, I guess. You have 4 functions that you can call, and using those 4 functions, you should be able to assemble really complex instructions, like in this case, trying to open a shell on the device and execute a simple command. When you execute command, you open the shell, but in order to open the shell, you need to send the open, which will fork that the ADB daemon into the shell. And then in order to do that, you need to actually send some proper handshake before it, but it didn't work. And that's when the whole rabbit hole started forming up, and it was just ripe for diving in. The CRC, it's not actually the CRC. It's some kind of implementation that they did. The magic had absolutely no reason. It wasn't documented what's the format, how it should be there. Is it really command, XOR, and the other, the list of Fs? Nobody kind of knew, and nobody kind of knew why that happened. Probably, just PMs breathing down your neck. Hey guys, how can we wrap this up faster and faster and add TCP/IP over ADB, or just finish it? Yeah, we're gonna bolt something together and let it be. So these are my attempts at sending, because in order to write that honeypot, I needed to reverse those 3 functions: connecting, sending a command, sending a binary. So I was trying to send a binary using the same devices on the same connection 3 times, and I got 3 different flows, totally different flows. Okay, let's say that the first part is kind of in line with the other. I mean, that's the handshaking part. But until we reach the actual stream of data, there's a different flow every time. And in the last example, you can actually see that there's like a big discrepancy over there. So what I did, I got the headers and the body of the message from an open source repository that I found and I was telling you about. And I just got to work. I basically implemented the send function, like a raw send function, and tried every corner case known to humanity until I could get 99% of the payloads. Let's say that there was this odd puppy that would come in sometimes and screw everything over. But let's say that in the end, it was a great success. I finally had a honeypot, and you can actually go and connect to it right now. The honeypot has been running for around 1.5 years and catching attacks all over the internet, bad guys that keep connecting to ADB and trying to exploit them and to deploy their malware over there. So you can go connect over there to my server and say, hi, don't worry, nothing is gonna happen. It's just like my private list of, my private zoo, actually, when it comes to malware. And speaking of zoo, let's get into some of the more interesting samples that I found. The first one got my heart rate a little bit up, made me seem like a bit wholesome. It looked like there's this guy going around on the internet stealing my original idea, thinking that, hey, I'm gonna make a botnet that is gonna fight with other botnets and clean the internet. Hey, look, this guy already decided to do that. I mean, he's removing like 1, 2, 3, 7 other miners from that device. And of course, he's deploying his own after he's doing that. So yeah, that's how my hope in humanity collapsed again. Very simple operation, shutting down his competitors and then trying to push his own APK using ADB push. And after that, he starts his APK. The APK starts mining, and not only that, in case that, who knows, maybe the user uninstalls the APK, he also has some scripts that download some binaries that do the mining. He's not relying only on the APK. At some point, came along a guy who kind of forgot that you can do ADB and push of a command, of a binary. So he escaped the payload behind hex, and then he tried to rebuild it, even though ADB shell commands like go in all directions everywhere, and it's not like always, especially over TCP/IP, that you're gonna have the same commands go in the same order, especially if the connection becomes this like close it at some point. He was short-lived, needless to say. And the Putin helper, yeah, this guy's nose representing, that's the actual name of the malware, Putin helper. It's some kind of DVR mining scam. Like most of the bad guys out there, it looks like mining is still going strong when it comes to Android botnets, mining and banking, making money. And I actually like felt sorry a bit for this guy. He's actually asking for a job over his botnet. For those who don't watch, he's saying, I'm sorry, but I'm mining on your device, not because I want to, but because I need the cash. And then he attaches his Proton Mail email and saying that he's gonna send you a CV if you contact him over there. Yeah, what can I say, buddy? Hoping that you got a job finally and renounced your ways. And now, Lapis de la Resistance. Trinity. Trinity is an interesting piece, mainly because it's the biggest malware that's going around the internet on these devices right now, which at their peak were about 50,000 or 60,000 Android devices. It's a bot. It's a bot that's comprised of the three parts: a native miner, an Android miner, and the spreading script. And all of these three components are pushed dynamically. So the bot, an infected device, let's say, will start scanning the internet. Then at some point, it will find a device that has the 555 port open. He's going to connect to it and see if the malware, the same strain of malware, is already running on that device. If it is, then it won't do anything. It will just leave it alone. If it's not running, it will check each of the individual pieces that I told you about: native miner, Java miner, spreading script, if they are running. If not, if one is not running, it will push it to the device and try to restart it in order to achieve this meta persistency mechanism. There's a lot to delve into it. A really cool researcher, NC Commander, made an analysis of it. I don't think he published the research yet, but basically this guy is actually infiltrating in the recovery partition, I think, if it found a rooted device. So he achieves this extra resilience over there. But anyhow, Java miner is really straightforward. It just embeds, it has a file embedded. It loads it in a web view, and inside that file, they just open a coin hive and make money. The native miner is just your run-of-the-mill mining binary for Monero, while the spreading script, this is the more interesting one that I was telling you about. It contains the routines required for all of that extra punch with embedding itself into the recovery partition and trying to spread around as much as it can. Now, Trinity was the most successful, but a close competitor to it was FBot, which got covered by the guys at Kihu, I think. And they discovered that it was using some kind of blockchain DNS system, like going all out blockchain money, blockchain DNS, blockchain everything. And at some point, they were specifically targeting Trinity over here. UFO miner, this is Trinity. And Cătălin Cimpanu actually made, I think for ZDNet, a really cool article about how these two botnets are actually fighting with each other on top of this network of devices that are ADB enabled into basically the ownership of your smart TV or smart home or smart whatever. But hey, Gabby, it's not that bad. Maybe these guys only had old devices. Nah, my sources told me that they are pretty new devices. Android 7, 8, 9, even Android 10 devices. You're gonna find everything in there. Which leaves us to the question, how did this happen? I mean, it's not like an active exploit or anything. It's something that is as designed. Probably somebody in the factory, when they were building the TVs, had this brilliant idea of enabling ADB over TCP/IP, connecting them to a Wi-Fi, and then just pushing the APK for like the QA process or that TV or that DVR, and just automating the process. And somehow they forgot to remove this debugging feature. I'm using this educated guess because it happened in the past. That's how I got to hack my Mazda before. they just left all of their debugging tools like on my machine, like on a production line machine, and not only for me, but for everybody else. But yeah, anyway, just a quick reminder, you can always connect and try to whack around my honeypot in order to maybe find a bug, who knows, and together we can improve it. By the way, the honeypot is available open source. It's written in Python, and last year it was upgraded to Python 3 as well. Everybody can just pop it and see what these guys are sending. But anyway, enough of the honeypot. I mean, I didn't talk enough about what can you find on those devices. So we're gonna have like a demo-ish, like a prepared demo. I know I'm cheating, but I couldn't have done it live. It's again from my sources. I can show you what can be seen on these devices. And I would kindly ask you that you don't like record this part, or let's say that you don't specifically target this part, because there are people behind those images. And we're gonna start with something light. Some bad guys just injected their ad fraud APK onto that device and are actually trying to test to see if they can get something done. More testing for ad fraud. These are just default ads from AdMob, and bam, they got it. They got an ad running. And how this happens, you just say, let's say that you have one of those TVs with ADB enabled, you plug it in, you connect it to the internet, and then you just get picked up by some of these bad guys, for example, like the ones that push ads. And you're gonna start seeing interstitial ads on your TV from now and then. Fun, right? This guy was just trying was in the process of being hacked. Somebody was just connecting to him and pushing one of the fraudulent APKs that roam around the internet on his device as all of this screen capture was going. Some random people watching watching YouTube, people playing games. You know, I mean, up until now, it's not that harmful, right? I mean, what can go bad? It can be. I mean, what are the hackers gonna do? Like use your CPU for mining time and see that you're watching Vikings? Well, how about porn? Yes. Zero privacy. If you're one of those devices, you've got zero privacy. Somebody can connect to it at any time and just use this as fresh ransom material. Or how about your messages that you're discussing with your loved ones or whatever, or just spying you while you're doing your, I don't know, actual human being stuff, trying to talk with your relatives, trying to, I don't know, use WhatsApp, and then here comes this jackass connecting to your phone and stealing sensitive information and your chat logs. And I had to do, I mean, that's when I knew that I had to do something. So I open sourced the honeypot, as I was telling you earlier, and I got fresh memes for, these were not made by me, these were made by some guys as a reaction to the honeypot being open source, which was like really, really, really wholesome. I mean, being kind of fresh in the InfoSec industry and basically piggybacking so much onto the knowledge that was shared with me by other people, I felt that I needed to give something back. So seeing a reaction to that, to this give back was just amazing. It was a really cool thing. Open source, best. 10 out of 10 would do again. And yeah, it got, the honeypot got integrated by the guys at Telecom into Teapot. which is really cool. You don't have to deploy it by yourself. You can just deploy Teapot, and you've got an ADB Honey instance running on by itself over there. The number of infected devices after I started evangelizing this decreased from more than 50K to 15K, and it even decreased more. This was last year. It decreased more this year to like 7K or something like that, but we'll get to that later. It keeps oscillating. Some interesting statistics. There is something wrong with June and July. Like, I'm not a really knowledgeable data science guy, but when the graph goes like this, it is bad, right? So we've got two spikes, one here and one here. And this was from last year. Lo and behold, the same spikes over here in June. I don't know what's going on, but it looks like the bad guys want to go on vacation, maybe, who knows? And yeah, they want to rake in some cash. Something really interesting is that they seem to have like a lower activity during the winter holidays. Maybe they just take time off. Being a malware guy, it can be hard, right? And taxing. Another interesting aftermath is that the number of devices keeps shifting up and down. For example, there were like 10,000 devices that were open on IPv6 a couple of months ago. Fortunately, in the meantime, somebody decided to shut that down. So the number dropped from 20K a couple of months ago to only 7K right now. And all of the IPv6 devices have pretty much gone in the dark. So somebody over there must have done something really well, and I thank him for that, because the botnet is still going strong. Even if if you get infected, and even if you shut down your internet connection after that, or sorry, you put your device behind a net, you're still gonna mine for that guy and try and spread the malware, basically. But at least we are seeing like a downward trend. And without further ado, follow me on GitHub for my latest project. I have some really cool stuff that I'm gonna be releasing soon. And follow me on Twitter for all the fresh memes. Thank you, guys. And thank you, the guys at Android Security Symposium, for having me.
Okay, thanks, Gabriel, for this animated, very meme-powered presentation. We're ready for another round of Q&A. There are two people in Zoom still raising their hands. I don't know whether or not you would like to ask questions, or maybe this is from your questions regarding Android development before. Claudia, do you want to ask a question? Okay, I don't think so. So if there are any questions, please just type them into the program, the one Q&A in MetaMost. Well, almost all of the questions I prepared during the first half of your speech, you actually answered in the second one. It seems that most bots you detected have their main focus on mining cryptocurrencies. Is that correct? Or
Yes.
did you find malware which tries to do anything else in particular?
Oh, it's mainly ad fraud and cryptocurrency. They are still exploring the ad fraud part, but the cryptocurrency is there to stay. They are mining like crazy.
Okay. Is mining on Android hardware, well, potentially, I don't know.
Yeah, exactly.
Interesting.
When it's not your device, any kind of mining is financially useful. You just need to find a reasonable amount of devices. I've seen people trying to mine on even a lower number of devices, like 1K, for example.
Okay.
And yeah, and it still rakes some profit for them.
Well, obviously they wouldn't do it otherwise, I guess.
Yeah.
There is another question from Renee, who asks, what's the plan B or C or D on recovering or resetting the honeypot when attackers manage to compromise the next level?
Oh, there is no next level. It's completely non-interactive. I mean, it's interactive, as in it responds to the various packets, like lower level packets that are being sent, because you just can't like make a handshake and then send a command. No, you need to like follow that protocol. So the whole ADB, I implemented the whole ADB protocol from the ground up, and the payload is just downloaded in a file, and the shell command is outputted to a text file. That's it. I mean, unless they find some kind of exploit in the honeypot in Python where they can do some shenanigans, there is no second level.
Okay, I guess that answers it. We have another question from Paul, who tells you you did a good job on your talk. Have you seen any malware from another source that attempts to turn on ADB over Wi-Fi? He also says he assumes that white hats can find these devices, ADB connect and disable ADB over Wi-Fi while connected, so that's some sort of the drop.
From my knowledge, the ADB, so the connection is permanent, like built in from the hard. So even if you disable it right now, when you reboot your device, it's gonna be re-enabled. I can't recall for sure. It depends from vendor to vendor, but I've seen one that did that. And this is one of the issues that I've noticed. It's a bit harder to patch it. Yeah, and to answer the first question, I haven't seen any malware trying to open ADB connections. And we're talking about Android malware like Google Play malware and stuff like that, or side channel malware, third-party malware. They don't do that. They either go like they wiggle their way through ADB, and they do all of their shenanigans, or you download them from a marketplace, whatever, and they just stay in the context of that device and don't do anything cross-channel.
Okay, thanks. Another question from Wikas. He asks, do you know what kind of devices are these, like a list of devices? Do you notify the vendors to fix it?
The list is really big. I tried, at some point I tried doing some recon, but the configurations that came were very diverse and colorful. And yeah, what can I say? Just gave up. It was basically whack-a-mole, because you would try to, let's say that you found a vendor, but then the next day you had like this other vendor, like the IPv6 guys that I was telling you about. They are some kind of DVR company from Brazil, and they just pop them overnight. They spread everywhere, like just like that. Fortunately, I'm trying like a more proactive approach. So I'm trying to speak about this and to raise awareness, hoping that this kind of knowledge will spread as much, like go right to the guys actually making this stuff and getting them informed, and fortunately shutting down ADB.
Okay, we'll see if that works. Hopefully it does. Okay. I do have a last concluding question, a more general one. So speaking of pushing system upgrades, especially devices like TVs have a notoriously bad track record for not being taken care of after manufacturing them, as far as I know, much worse even than it is the case with some smartphone manufacturers. So do you have the impression that companies which are using Android for devices other than smartphones care significantly less about the security of their devices?
I don't think that care would be the correct verb. I would say that they just don't know.
Yeah.
It's like, let's say that you're making TVs and all of a sudden there's this requirement from the management. Hey guys, you need to make a smart TV. Yeah, but we need to like release in a couple of months. We don't care. It has to be smart. So then you have devs just rushing and bolting things together. And I mean, I know because I've been in that situation. I've written some bad code and I feel guilty about it. So
Okay.
I think that this is happening. It's a leitmotif in our industry.
Yeah, from what I know, I'm afraid you're right about that. Okay, it seems like there aren't any questions left to be answered. So thank you very much once again, Gabriel. Thank you very much for your talk.